let's do another. All right, there's our table. Oh, shoot, let me write something down. Let's make sure we have it. So we're going to deal with an A. Just an A. Maybe it's 7, maybe it's 6, maybe it's 1,003. Let's get after it. Now, there's two different ways of getting through this problem. There's trigonometric substitutions, and then there's hyperbolic substitution. So you tell me which one of the n. I'm going to do them both. You tell me which one you like better. All right. Let's go. Let's go. Now, we're going to say here that we have this setup going on. X squared minus a squared. So we're in letter A be secant of theta. Because a squared secant squared of theta is just a squared tangent of theta. So we're going to kind of jump a little bit of steps. We're going to take the training wheels off a bit. So we have x squared. We don't want the x squared. We want to sub in for the x squared. Come on, my dude. So what did we want to make x? We wanted to make x, what was it? Oh, yeah. A times secant of theta. And then that means dx is equal to a times secant of theta, tangent of theta, d theta. All right. So let's replace back in. A secant theta, and now we have to multiply by a secant theta, tangent theta, d theta, so we could replace him for our dx. Okay. Well, that means we have an a up top, secant of theta, tangent of theta, no biggie, d theta. Now, a squared secant squared minus a squared. This just becomes a squared tangent squared of theta, jumping the steps. Now we're using, for when our a value is x is equal to a, we're actually greater than or equal to a. So we're either in the first or the third quadrant, and it's actually not going to make much difference for you. Just going to do one of these. I'm going to put it in the first quadrant. All right, sorry, I don't know. I got sidetracked. I was thinking about something else. I'm back to this problem. So now once we clean it up, so our tangent's going to be positive here. We don't have to stress out about this at all. When we take, that's why I got sidetracked. I'm like, how did I get so sidetracked? I was like, let's make a triangle. There it cleans up. Just need to make sure when you take the square root of a square, it's going to just turn out the way we want it. So the a's cancel, the tangents cancel, and the only thing we're left with is the integral of secant of theta, d theta. Are you going to build that again, or do you have it memorized yet? How many times do you want to like miss points before you get it memorized? Or maybe you're one of those saying, hey dude, I had that thing locked in for a while. Cool. And some of y'all might be learning this stuff at home, going like, oh, just write it down. It's sitting next to me. You have to take tests on ground. You have to memorize the stuff. Don't be short-sighted. All right, let's go. So the integral of secant of theta, no biggie. This is just equal to the natural log of secant of theta plus tangent of theta. Of course, plus c, but we have to go through and solve for all those things. So let's go back to our substitution. So if we take this out, we're like, all right, x over a is equal to secant of theta. Well, there's secant of theta. We got that one already. That's nice. Well, what's secant? Secant is the adjacent. No, it's the hypotenuse over the adjacent. That's right. And then give you 3 guesses what this side's going to be. It's the square root of x squared minus a squared. And of course, this is our theta. Well, can you solve for secant and for tangent? Well, yeah, we already got secant. So this is equal to the natural log, and we already found out the secant was x over a. And now we just need tangent, which is going to be the opposite over the adjacent. All plus c. And there's our solution. Okay, so there was one way. There was one way. There was one way. Now let me show you a different way. And it's up to you. Maybe you're like, nah, dude, I can do this. This is fine for me. Whoa, that's an X. Sorry. All right. Do we know our fundamental, do we know this? You know, that like cosh of X minus sinh of X is equal to 1. You know that? And, maybe we could do this. Maybe sinh of X is equal to, do some manipulation, moving it around, and you get that it's, oops, these are all squared. I'm so stupid. Well, let's change them all to t's, and then maybe we can do a substitution. Do we see that we have something squared minus 1? So why don't we go through and let's let x equal, oops, a times cosh of t. So as long as we know that fundamental identity, this is just one spot where these pop out kind of quickly. And it's a little more simple. So I'm not using a theta because there's not an angle here. We're using a t. So let's do our substitution. So we're going to replace it with a cosh of t for that. And then we're going to have a times sinh of t dt. Okay. Where do we end up? Well, we have a times sinh of t all over a squared cosh squared of t minus a squared. And all this is dt, but you can take out that and you're left with cosh of t minus 1 over a times sinh of t squared. I keep losing my squared, but that's equal to sinh squared underneath the square root. The a's cancel out. You have the square root of sinh of t squared. They just cancel. They just cancel. Oh my goodness. So the answer is just t plus c. But we started in terms of x's, which means we need to solve for this t. So we move it over, we divide by a, and we're like, all right, so cosh of t is equal to x over a, but we want that t out of there, so we're going to hit it with its inverse on both sides. And we're going to find out that t is equal to cosh inverse of x over a. And there's our answer. And we didn't even need to make a triangle. So there are multiple ways through this problem. It's really when it pops up and you have this. It's the x squared minus a squared. You could use this identity. But I think, I don't know, they're pretty much equally difficult in my opinion. But they look different, but it's the same gosh darn thing. So take it or leave it. It is what it is. Yeah, let's be done. Let's move on to the next video. Take it easy.